So this week we are tasked to build a decentralized donation app, and this app will be we're going to be building a smart contract that will allow anyone to donate funds securely, with transparency and all the features that blockchain offers. So that's a project we'll be doing for the week. All right, so let's open the project. Let's go to Classroom. Then we navigate to find the project for the week. All right, so this is what we're working on. Um, Mastery code with sex project, and then I'll open the document. All right, so we are there, and then we have to start reading from the beginning. All right, so part one, setting up your environment. So as usual, to start building a project, you have to first set up your environment, and the objective here is that you prepare your development environment for creating a secure, feature-rich donation contract. So we'll be using Remix as usual to build this contract. All right, so let's look at the instructions. We have to set up Remix IDE. This is what we've been doing. So we'll open Remix and clean up your workspace, then create the following files. All right, so we'll create the following file: donation.so, the main contract. So this is the main contract that we'll be building for the week, and that's what we'll be creating when we open Remix. Then we configure MetaMask for Sepolia Testnet, and after you open Remix, clean your environment, then you also make sure that the MetaMask is switched to the Sepolia network. That's Ethereum Sepolia network. And then you also fund your wallet with Sepolia test. That is, if you do not have enough Sepolia for your deployment, you need to fund your account to be able to deploy or to be able to make any transaction. Okay, so let's tackle part one first before we move to the next part. All right, so let's go to Remix. Go to Remix, and then, like I always say, when you get to, because you'll be pushing your work to GitHub, it's always good that when you get here, you create a new workspace and name it, and give it a name of the project that you'll be working on. So when you push it to GitHub, it makes more sense that you can easily, make reference to what you're pushing there. So what we're going to be doing here is to create a new workspace. So this is not part of, this was not captured in the project, but we suppose, we believe very well that you know what to do when you get here, because you need to create a workspace to work on your project. So let's create a new workspace. All right, then I'll call this one, then we'll call it donation app. I'll just call it donation app, like this. No, I'll say donation contract. Donation contract. Let me do it this way. Donation contract. So this is the workspace. Okay, so a new workspace is created. All right. So this one is a default file. Prettier. Prettier is a file or an extension that organizes your code to make it look beautiful. All right. So I'll just go to delete it. I know it will be added later when I start formatting the code, but I'll just delete it to make sure that the workspace is very clean. All right, the next thing we need to do is to create the contract file. How do you do that? We create a new file here, then we call it donation. So donation.so, this is a new contract that we'll be creating, and then let's look at what we are doing here. So it says create donation.so, that's the main. Then after that, we now configure MetaMask for Sepolia testnet. So we have to switch, we have to make sure that our MetaMask is on the Sepolia testnet, and then if we do not have any funds there, we have to make sure that we have enough funds for our deployment purposes. Okay, so let me open my MetaMask. Okay, so this is my MetaMask. I'll expand the view to see very well. Okay, so here I can see that my MetaMask is already set to Sepolia. So if yours is not set to Sepolia, you should make sure that you set it to Sepolia under the show test networks. You should be on the Sepolia. So this is the Ethereum main test net. So you'll be on Sepolia. Okay, then you also make sure that you have some funds in your wallet. All right, so if you get to Sepolia, you should have some funds in your wallet. If you don't have any funds, you try to fund your account. If not, you cannot perform any transaction. All right, so we are done with part one. Let's move to the next part. This is very quick. We'll move to the next part. This is where the main work is. And part two says that part two is about writing the donation contract. And the objective is to implement the core functionality of the donation contract, including funding, withdrawals, and then security features. So this is what we'll be doing under this part. Alright, now let's go to the instructions to see what the steps we'll be following. Alright, so first instruction says that we should start with a basic contract. So we start with a basic contract. Remember, we have the code, or all of these steps, we have it inside the HackerBoost Solidity program 101. So when you get here, we have to create the basic structure of the donation file or the donation contract that we're coming to do. Then inside the structure, we have to create the contractor function that will set the deployer as the contract owner. So take note of this. This is what we'll be doing. Alright, so we can just write this by going to Remix. Then we start with Pragma and all of that. To start with the version that we'll be using 0. Let me say this, then 0.8.25. I think I'll use 2.5 or 2.6. Let me use 2.5. So we can start it this way. Then we go to contract. Then we call it donation. So this is a basic structure of the donation contract. Then it also says that inside this contract we must have a contractor function that will set the owner of the contract as the deployer of this contract. Okay, so to make this video very short, I'm not going to write everything. What I will do is that I will clean here, then I'll go to HackerBoost. Alright, so I'll go to HackerBoost. I'll go to Solidity Program 101. Okay, then let me get to the course. Alright, so let's get to the final part of it. Donation app project. Alright, so here now we can see the basic structure of the donation contract. Let's look for it. So this is the basic structure for the donation contract. So instead of writing everything, I'll just copy this one, but I always recommend that you write it, type it, do not copy. But I'm making this video and I want it to be very short, so I'll copy and then I'll explain to you guys. I know you already know this, but I'll explain that to you, just to make sure that even if somebody is not participating in this bootcamp, the person can still understand what we are doing in this video. So I'll just copy this, I'll go back to Remix, and then I'll paste it. So this is the basic structure of instructions in part 2. It says create a donation soul file, write a constructor to set the deployer as a contract owner. Okay, so we start with alliances, and then the Solidity version that we'll be using 0.8.25 and above, and then the contract name is donation. So this is a contract name, donation. And then inside the contract, we are asked to also create a constructor function that will set the deployer of this contract as the owner of the contract. Now don't get confused. One thing about the constructor function, you can read more about this when you get to when you open the Solidity programming 101, we have the Solidity syntax, the fundamentals of Solidity syntax and all of that. You can go there and read more about what a constructor function is. But to just make it very brief here, the constructor function is a function that during deployment it only runs once. So the time you are deploying the function, the time you are deploying the construct, that is the time the constructor function works, and it only works at that time, as once, and it will never run again. That is why we are asked to set the owner of this particular contract as the deployer of the contract. So because this particular constructor function, it runs once during deployment, now the person that will be deploying this particular contract is the message.sender. So that particular person will be interacting with his address, right? You have to connect to deploy a contract. You have to connect to your wallet, and then you now go to deployment, and when you deploy, you will confirm in your wallet. Now you, the person confirming, your address is going to be captured in the contract as you being the owner of this particular contract. So that is why here we have this particular state variable, which is an address, because as the owner of a contract, we can only track you based on your address. So the account you use to deploy the contract, that is, so we have a public variable here we call the owner, and it is a public variable so that you can get a getter function on it. And then inside this constructor function that will only run once during deployment, we have assigned the message.sender, that is the address that will be interacting with the contract at that time, to this particular variable owner. Okay, so this is very simple. So after you deploy this contract, the variable here will now be initialized to contain or to have the value of your address or the address of the person that deployed the contract. So that is why we have message.sender. So this message.sender is a global variable in Solidity programming. We have everything in the Solidity programming 101 course. When you get to where we have variables and all of that, you read about the message.sender. Even if you cannot find it there, we have the Solidity documentation as a reference where you can read more about the message.sender global variable. Right? So anytime you say message.sender, it means that the person interacting with the contract at that particular time is going to, this particular message.sender will capture the address of that particular person. All right? Because this particular constructor is running at the time of deployment, your address or the deployer address will be captured and assigned to this particular state variable. And what it means is that anytime you now see the owner in the contract, it means that the person that deployed the contract is the owner, or is going to be the one you are referring to in the contract. Okay, so we have spent time here. Anyway, I hope you understand. Let's move to the next part. So the next part is implement funding. So we're going to be implementing the funding function, and then let's look under that what we're supposed to do. It says use a mapping to track donations, that is, keep track of each address and value contributed. So we're going to create the funding function, but we have to do this before we start creating the function. All right, so that's why it says that we should use a mapping to track donations. So again, you should understand what mapping is. If you don't know about it, you read that in the course. We have an explanation and examples for what mapping is. So if somebody is going to donate in the contract, we need to keep track of each address and the amount that it donated. Okay, so if we have the app or the application and somebody want to donate, the person will call the donation function, and the person is calling the donation function with his address. So we're going to use the mapping to keep track of the address and then the amount that the person donated. So that is why it says here that use a mapping to track donations. So when you take donations, inside donations, we should be able to see several addresses, each with the amount donated. All right. So mapping will be implemented here. Then the next thing says that we should use an array of addresses, to store the addresses of the funders or the donors. So what this one would do, so unlike the mapping, which is only going to be like, it will map an address or a key to a particular value, right? Like map an address to a particular value. This particular array of an address is not going to be mapping an address with a value, but rather there's going to be an array of addresses that will contain the addresses of all those who have donated. So if you call the address array, you will see a list of all the addresses that have donated in the contract so far. So that is what this particular this particular address, or this particular part, the array of address, will do. The next thing says that we should add a fund function to accept donations. So you cannot even create this fund function if you do not implement the mapping and then the address array. That's why they came first before this one, right? So after implementing this one, we now have the fund, and then we have the emit a donation receive event. So this one will lock anytime somebody make a donation, the event function will emit, it will lock down there. So it's like notification on your phone. So whenever you make a transaction, like let's use mobile money as an example. Whenever you make a mobile money transaction, you get a message that tells you that so and so amount was removed at this time, this and that, stuff like that. So you need to have a donation receive event that will do all this for you. Okay, so let's go to implement that. Now we are going to implement the funding function. All right, so we can get that in the course. Let's go to Solidity Program 101, and then here we have the fund and withdrawal functions. So inside here we can find the functions that we want to implement. So here we are looking for the fund function. Okay, so inside this boiler code, let's search through to find the fund function. So this is the fund function. Alright, so we could type this one. Normally you need to understand what you are doing, so I always prefer I type, but we're going to copy this and send, then I'll explain to you. So we copy this. This is a function we are looking, but no, we cannot copy this. First, we are asked to implement a mapping and then address before this. So let's first look for a mapping in the code that will keep track of addresses, an address to a value. So here we have track donations by address. So we have a mapping here, and this mapping, inside this mapping, we have an address to a value. So every address has a particular value in number. That's why it is a uint 256, an unsigned integer in the form of 256 shy 256, stuff like that. So we're going to be copying this mapping, and then we bring it here. Should bring it to the top as a state variable, and then the next one also says what? An array of addresses. So let's look for that one too. An array of addresses. Here is it. So address array, and then we call it funders. So you copy this one too. Alright, then I have it down as this. Okay, so a mapping, public donations. So when you pick donations will contain addresses with the amount they have contributed or they have donated. So this is what donations will do. So for instance, whenever you take let me make an example. Whenever you take like donations, donations, and then you do like this, and then you put an address, any address in there. It should equate to the value or the amount contributed so far in the contract. Alright, so that is what it means. If you know arrays, this should not confuse you. And then we also have funders, which is also an array of addresses. So whenever you call the funders, you will see that a list will come out containing all the addresses that have contributed so far. And like I said, this one is not going to have value attached to each. You just see a list of the addresses contributed. Okay, so after this, it says the next thing is to create the fan function. So let's go back to the code, look for the fan function. It is here. This is a fan function, so I'll copy it. Copy. That one should come under here. Okay, all right, so I just pasted it, but you can see that there is an error. We have red, there's an error, and this is the error. Why do we have this error? So ask yourself, why do we have this error? The reason why this error is there is because to emit an event, you have to first define the event at the top of the contract. Okay, so that is why you cannot emit an event if you don't declare the event. So we have to declare the event first. Now we need an event called donation received, and this one too can be found in the code. So when you go to the top, you see, okay, here, event donation received, which takes an address of donor and then an amount. Okay, and you use index because it makes the locks to be queryable, like you can easily query them. So on the blockchain, any lock will be indexed, and that's why index is here. All right, so copy this one, and then we have that one to under here. Have it here, and you know what happened after pasting it? You can now realize that the error is gone. Yes, so what you need to do always, before you can emit an event, you have to declare the event. So here we have event donation received, and then here we are emitting the event. So whenever somebody make a donation, we're going to emit by taking that particular person address and then the value that the person has contributed. Then we lock it, will lock on the blockchain. So that's what this means, and it can be queried by people even off-chain apps can query on the blockchain using events, emissions, stuff like that. So now we have the fan function. Let's look at what the fan function is. So this fan function is a payable function. Payable function is a function that that receives ether, or it helps you to like send ether or receive ether in the contract. Okay, so it's like instead of we having, let's say, an argument here. Let's say we had an argument that say uint amount, stuff like this, so that this one takes an amount and then it assigns it to what and what. Now if you are using a payable function, if you add this payable modifier, it turns this particular function to it makes this particular function to be able to receive or retrieve ether. Okay, so that's why we have here as payable. Then when you add payable, when you deploy, you see that when you call that function, it will ask you to input an amount in it. So that's why we have here as a message.value. So this message.value too is a global variable in Solidity programming, and what it does is that it retrieves any amount in the contract. All right, and it helps you to put value inside the contract. So once message or sender retrieves your address or retrieves the one interacting with the contract address, with message.value it, it retrieves the the ether, or it helps you to put ether in the contract. So here we have a requirement. Before somebody can perform a transaction with the fund function, we have to first require that the person must input an amount which is greater than 0. So you cannot just call this function if you don't put an amount which is more than 0. So that's why we have this requirement here. Method of value is greater than 0. So if whenever somebody wants to call this function, the person do not input an amount which is more than 0, this particular error message will be thrown out. Donation must be greater than 0. So this is what we have now in the contract. And if this particular condition is fulfilled, we move to the next line of the code, which says that inside here we're now going to take the mapping, that is the donations map, and then we input the person calling the contract, the person calling the function at this time. Address will be captured, and then the value that the person inputted will now be assigned to his address. So all of this now is about you understanding what mapping is. Okay, so when you come here, donations, then inside the donations, we say that donation contain an address mapped to a key or mapped to a value. Okay, so now here, donations, the address that is calling the function will be assigned a value that he or she is inputting to the contract. So now whenever you call donations and you input the address of the person, you can retrieve the value that the person donated or contributed to the contract. So that's what this particular line means. And then after the person donates, we assign the value the person has sent to the contract to his address. The next thing is that we are going to push his address into the array of funders. Okay, so anytime somebody donates, we assign the value in the mapping to his address, and then we move to the next line and add his address to the funder's address. Okay, then after that we emit a donation received event that will lock everything about what he did in the contract on the blockchain. So that's what this means. Okay, so let's compile to see that we are on track, to see that we do not have any error. Let's compile. Okay, so code is compiled. Great. All right, now let's move to the next stage. Next part says that enforce minimum USD donation. Okay, so in the previous week you did importation and Solidity programming, and you also did inheritance and all of that. So you're going to be implementing that in this particular project. So here it says we should enforce minimum USD donation. So use the price converter library to convert Ethereum to USD. Now, what are we going to do under here? We'll create the price converter.sol file, then use Chainlink's aggregator v3 interface to fetch the Ethereum or USD price. Implement a get conversion rate function. So all of this, we have a boilerplate code, right? I mentioned it well. We have it for you in the Solidity. Then we also say after you create this price converter sol file, and then you add all of this inside it, you're now going to integrate it into your donation.sol file. So that is, you import it into the contract, and then you now use it over there, and you use the library to enforce the minimum USD requirement. So what it means is that currently, if you check here, currently in the fund function, we only require that the person calling the function must input an amount which is greater than 0. But now this particular step is telling us that we must implement or enforce a minimum requirement of $50. So if the person is inputting an amount which is less than $50, the function will throw an error and tells the person that no, you must input an amount which is more than $50. Okay, so this is to prevent like somebody coming to donate less than $50 or any smaller amount. So the contract will enforce that you can only donate $50 and above. Now, how do we do that? To do this, you have to always make sure that you fetch. We have to always make sure that we implement a function that will fetch the actual price at the moment of Ethereum in dollars. So when you input $50, when you input an amount, it should tell you that this amount is $50 or is less than $50 or is more than $50. So this price converter function will help us to achieve that. So that's what it means. Okay. So first, what we have to do here is to create the price converter .sol file. So I'll just copy it like this, and then we go back to the workspace here. Then inside here, I'll create a new file and price converter .sol file. So after creating this file, so what you should understand is that we are integrating Chainlink. So that means this is an oracle. So if you go here, if you come to Solidity programming, you look for integrate oracles for dynamic goals. So let's check oracles. We are asked to create a price converter .sol, and this is the boilerplate code for that. So you don't need to waste time here. You can copy this code and then put it there, and inside this code we have this particular contract address, which is the Ethereum Sepolia address. All right, so that is for this particular library. Okay, so you can just copy this, come here and paste it. All right, so when you check here, it asks that we use Chainlink's aggregator v3 interface to fetch Ethereum USD price. Then we implement a get conversion function. So all of these two things are inside this code we just copied. So interface aggregator v3 interface. All right, and then we have library price converter, and inside this library we have this function get conversion rate. So we have this, which was asked to be done in the project instructions. Okay, so we are done with this part. We move to the next part. It says integrate price conversion in donation file. And then what are we supposed to do? We have to import the price converter into the main contract, then use the library to enforce the minimum USD requirements in the fund function. So let's go and do that. So now that we have the file, this is the file, we have to import this file into the donation contract. You know how to import. So we say import, and then price converter .sol. Okay, so you have to get it. Now we have it there. Okay, importation is done. So after you import, use the library to enforce the minimum USD requirement in this. So let's go and check something. We could do this ourselves by just getting a constant. We give it the back. Let's not waste time. If you are doing this, you should learn. So don't just. But let's move down here and see how it is enforced in the code. Okay, so this is the fund. Let's now look at the fund function. Now the requirement in the previous, like here, the requirement currently is about only 0. But in the new requirement, we are asked that it should rather be a minimum of $50. So we have to now copy this requirement and replace it with a zero requirement here. Replace it here. But let me format it to look nice. Where's my format? Okay. I can find something like this. Okay. So I've replaced the previous requirement with the new requirement, but there is an error. So now we have required message.value.getConversion rate, which is being retrieved from the import that we have here, should now be greater than or equal to a minimum USD. And what is the minimum USD? The minimum USD is the $50. So we have to have a state variable that will be assigned $50. How is it done? Let's go here. Let's go back here. Go to the top. You will see that we have a variable here, which is called public constant minimum USD is equal to $50, 50 times this. So this is a Solidity to convert this I think from way or what. So the conversion, this you can learn more about this, but this is how the conversion is done. So when we get here, we just copy this one, we go back to the code, the state variable, it's a constant state variable, then we paste it. Okay, so we paste it, and after pasting we have another error. Let me see, member get not found or not visible after argument dependent. Okay, so let's check what it means. Probably we didn't import it well. Let me try to just copy this, then I'll go back to the code and paste it. Get conversion type member get conversion rates not found or not visible after argument dependent. Look. Okay. So here you need to take your time to analyze the error. All this is part of the coding. You have to always understand what the problem is talking about. Okay, all right, so what we are missing here is that over here we are calling get conversion rate as a method on a uint, that's a value. And to do this in Solidity, when you import a contract like this and you want to directly access these functions like we are accessing it here, then you have to add a line at the top here, something like this. We have to add a line here, say using, then we call the price converter, the one we imported, for uint 256. So without this we cannot call something like this. Okay, so you guys learned importation last week and you didn't actually have something like this, but this one makes the code looks cleaner and beautiful. All right, but if you don't also want to do it this way, you can do something like this. So if you don't want to have this, which is part of the, you can still do something like this, dot, and then we pass the message.value as an argument. So we can still do it like this to achieve the same, last week this is what you were doing. So if you import a contract and you want to access the, you want to access the functions, this is how you were doing. You have to just call the file name, then dot, then you now access the the function. So contract is like class in object-oriented programming in JavaScript. All right, but in this code we are not doing it this way because we want to make the code look beautiful, and we are using the using as we are using the using line, using price converter for uint 256. This is what we're going to be using. So because of that, here I'll pick up this, and then I will say message dot value dot this. Okay, so when you go to the code, we didn't actually copy that, but it's here. Okay, it's here. So the reason why we had that error was because we didn't have this particular line. All right, so now we have the line and the error is gone. Okay, so let's go back to the project. It says use the library to enforce a minimum of $50. Okay, so that is now done. Okay, so instead of 0, now if somebody is calling this fan function, the requirement, this condition has to first check the message.value, that's the amount the person is inputting, this particular message.value will first call the conversion function inside the library we imported, and then whatever you put in there, it converts it into dollars, and the conversion, the dollar amount that is going to be converting should be greater than or equal to this variable, and the value of this variable is what? $50, right? 50. So whatever you input here in Ethereum terms will be converted, to achieve to make sure that this condition is satisfied. If it is not satisfied, you get an error which says minimum donation is $50. Okay, so we have something here. I don't know why. Let me come back to see. Okay, it has gone. All right, so we are done with that part. Integrate price conversion, use the library to enforce. We are done. We are moving to the next instruction 4. Add a withdrawal functionality. All right, so this fan function will help you to input money or to donate money into the contract, but the contract owner will want to withdraw the money that people donate into the contract. How does that happen? You have to implement a withdrawal functionality, and that is what we're doing next. So this is a payable function. The next function we'll be implementing is the withdrawal function. And again, let's go back to fund and withdrawal functions. So this lesson we should be able to find the withdrawal function. Okay, so this is a withdrawal function. Okay, so let's copy the function. Let's copy the withdrawal function. I know that there's going to be error when you copy, but let's copy first and then you put it there and see what will happen. We copy the withdrawal function, and then we send it there and paste. Okay, and then we have an error. Where is the error? This is the error. Only owner. When we take it out, the error will vanish. No? So when you take it out, we have another error. Fund withdrawn error. Let's take that one out, and now we don't have error. Okay, so now we have the withdrawal function here, and what it does is that when the contract owner, okay, so first before I explain that, let me come back here. Add withdrawal functionality inside. Implement a withdrawal function to allow the withdrawal of funds. Prevent a re-entrance attacks. Use the checks effect instructions pattern in the withdrawal function. Restrict access to sensitive functions. So add an only owner modifier to restrict withdrawals to the owner. Then after that, we emit a funds withdrawn event for transparency. Okay, so even though the contract owner is the one in charge of the funds, but this is a blockchain based app, so whatever is happening has to be transparent. So even if the contract owner is withdrawing the money that we donate or people donate to the fund to the contract, whatever the person is doing on the blockchain or with that particular money is going to be logged on the blockchain, from these emissions for transparency, and people can query, to know whatever is happening with that particular application or with the money they are donating to the contract. Okay, so that is what this particular thing. And here we are asked to also prevent re-entrance attacks. So re-entrance attacks are, the requirements that you see in the functions. Require this and that to be done before this will go. So it's like in JavaScript we say if, the if conditions. If this and this, then do this, else do this, right? So requirement, if else conditions in Solidity, we use these requirements in the functions, to require that this must be done before this, will take place. So that's what it means. We should implement the checks, prevent re-entrance, and then restrict access to sensitive functions. Then we have to add an only owner modifier. You know what modifiers are. If you don't know it, you should go and do a revision. So add an only owner modifier to restrict withdrawals to the owner. Okay, so that's why we have to remove only owner here to prevent the error. If not, before you add only owner, you must first implement the function, but we don't have the function here. Okay, we don't have the function here, so we have to implement the function first. You have to implement the modifier. So let's go back to the code and look for the only owner modifier. This is the only owner modifier. I'll just copy it, come back to the project, and I will paste it. Let me paste it here. I'll paste it here. Alright, so modifier only owner, and now you can see that the error is gone because the function is now implemented. Now let's look at what the modifier does. So the modifier restricts access to owner only functions. So modifier only owner. Inside this modifier, so anytime somebody is calling this particular function, the function has to check to see that this particular person calling the function is the owner of the contract. Okay, and remember, during deployment there is a constructor that will assign the deployer address to the owner variable. So that means that after the deployment of this particular contract, the owner variable is now going to be assigned the value of the address that deployed the contract, and now that particular address is the owner of the contract. So that's why inside this particular modifier we have a modifier, then the name of the modifier is only owner, and inside, let's look at the definition. It says require message.sender, that is the person calling the function at this particular time, is the owner of the contract, because this owner has a value, and the value is the address of the person that deployed the contract. So, and when you have a modifier function like this, to enforce it on a function, you just add it here, just like how it is added here. Okay, so modifiers make the code look more organized, but even if you don't want to use a modifier, you know what to do, right? You can just copy this, require this and this and this. So even if we don't want to use modifier, we can still copy this line, and then we bring it here. We bring it here and put it, and then we take this one out. And still, if you have something like this, you will still achieve the same thing. Okay, the person calling this particular function will have to pass through this requirement. The function will first have to check to see whether the message.sender, that's the address calling the function, is the owner of this contract. If the person is not the owner, it will throw an error saying only the owner can withdraw funds. But here we are asked to implement a modifier. Okay, so we have to take this one out, and then it should be inside a modifier. So where is the modifier? Okay, I have to go and copy the modifier again. So it should be inside the modifier. Okay, so contractor, so down, then put it here, modifier, and now I can copy the modifier and put it here. Okay, so this is what we are asked to do. Okay, and then here now we're asked to prevent re-entrance attacks. Okay, that is there. I can see re-entrance attacks preventions here. So, and then so first this particular condition will be checked, which is the modifier condition, to make sure that only the owner of this contract can withdraw funds out of this contract. And then after that, there is a variable, a local variable initialized here, and it is called contract balance. And to get the balance of the contract, that is the money inside this particular contract, you use this particular, we have address and then the this dot balance. So whenever you see this, I don't know how to explain this, but it is a common keyword in JavaScript. So address this dot balance. What it means is that this contract address, the balance inside this contract address, should be assigned to this variable called contract balance. That is what it means. Address into bracket this dot balance. So this contract address dot balance, so access the balance of this particular contract. Every contract, the only way to access a contract after it is deployed is through its contract address, right? So every contract address has a balance feature in it. So if you want to get the balance of that particular contract, you're just going to use this particular thing, address in the bracket this dot the balance, that will retrieve the balance inside that particular contract, and then we assign it to the contract balance. And then there is a requirement here that says that the contract balance should be greater than 0. So whenever the owner of the contract wants to withdraw funds from the contract, this particular requirement has to first check to see that there is money inside the contract. So if there's no money inside the contract, there will be an error message that says that no funds to withdraw. Okay, so if the contract has 0, but if the contract has even 0.001 ether, if the person hits on withdraw, the funds will be withdrawn. But if it is 0, no funds to withdraw. And then after that is done, transfer all funds to the owner. So we use this particular bool success, owner.call. So owner, you know who the owner is. That's the address who deployed it, the address of the person that deployed it. This is a variable, the state variable. We all know about this. We already talked about it. Then .call. This is another keyword in Solidity. So the owner .call, and then the value. So it's an object which takes a value, and then the contract balance, this one that was declared here, and then the contract balance, and then that is it. So it's just a simple function that you can use to withdraw all the funds inside the contract. Alright, so we are done with that part. Add a withdrawal functionality. We are done with the withdrawal functionality, and then the next part is test edge cases. Let's look at the edge cases we have to test. Verify that unauthorized users cannot call the withdrawal function. Okay, let's verify. Okay, so an authorized person cannot withdraw. Yes, we have the only owner modifier, which means that no person can withdraw the money inside from the contract unless the contract owner, because the definition inside the modifier shows that. Okay, it also says that next, ensure the fund function reverse for donations below the minimum requirement. Okay, we have that one too implemented. So minimum requirement dollars is 50. Okay, so message.value.get conversion rate should be greater than or equal to this. If not, minimum donation is error. So that one too is implemented. And to confirm that really serious, you need to compile and deploy your contract and just test it. So instead of just going through the reason why I'm going through it this way, it's just to make sure the video is short. If not, you should compile and deploy and test it. We're going to do that in a jiffy. We're going to test all these edge cases to see that they are really implemented. And then the last part says that handle fallback donations. So we should add a receive function to handle direct Ethereum transfers. Okay, so let's go back to the code. This one we're not going to waste time. And then we look for the receive function. Is it here? Receive function. I think it should be somewhere. Okay, so here's it. So a fallback function. So adding a fallback function ensures your contract can handle unexpected ETH transfers gratefully. So we are going to have this particular function to add it. And okay, all right. So you can either add it or you don't add it. Okay, I don't prefer you add it. You can add it or don't add it. You can just leave it. It's not necessary, so you can leave it. And then let's look at the next key features. So use the call for withdrawals to prevent re-entrance attack. We did that. Validate inputs to ensure donations are above 0. Okay, so all of this is done. Okay, let's move to the next part. Part 3: deploying and testing. Deploy the contract on the Arbitrum Sepolia. No, we are not using Arbitrum Sepolia. So we have to rather deploy on the Ethereum Sepolia network. Okay, so I am correcting that. Should deploy on the Ethereum. Okay, Ethereum testnet and validate its functionality instructions. Alright, so let's look at what to do. Deploy the donation contract on. Wow, that's still a mistake. So we didn't correct this once. It's supposed to be Ethereum, not Arbitrum. Okay, so provide a chain link at price feed address, something like this. Okay, so this one we don't even need to provide it because it is already provided in the library. So it is enforced in the library when you deploy it, so you don't even need to provide it, but it is here. Don't mind it. Then we say test contract instructions. So after you deploy, you're now going to test, and you're not going to interact with the contract. And then what we're going to do, we're going to use the fund function, and then verify donation received event is emitted. Then we're going to call the withdraw function as the owner and verify the funds withdrawn event as emitted, and then handle edge cases. Okay, so this is what we'll be doing. Okay, so this particular bonus you either decide to do or you don't do as well. So the most important thing here is to make sure that you get to this level, you deploy and test your contract, and that's what we're going to do. Let's deploy and test. So we'll go back to Remix. So first is to compile, and you have to compile both files. We have two files here. Remember, we have the donation, which is the main donation.sold file, which is the main contract. We also have the price converter.sold, which is also the one we use to convert prices. So we have to compile both. First, let's compile the donation. Make sure that it's here. So compile. Okay, that is done. Let's go back to price converter. Then also compile that one too. Okay. So after you compile, you deploy. Okay. So remember, we are deploying on Ethereum Sepolia. So on your MetaMask, Sepolia should be the one selected, and you should have funds inside. So let's go and then connect to injected provider. Okay, that is connected. So first, deploy the price converter. This one is an abstract contract, so don't select that one. Select the price converter file and then deploy that one first. So let's deploy it. As usual. So we have to deploy, confirm. Okay. So let me see where deployment. Alright, good. So deployment is done. You can check it on Etherscan. Now let's deploy the main contract. After deploying this one, we deploy the main contract. Let's select the contract and it will be selected here. Then we deploy the main contract. Click on deployment. Okay, so MetaMask just pop up for confirmation. I confirmed. Alright, so waiting for deployment. Great, that one too is deployed and you can view it on Etherscan. Let me click to view it. Okay, so this Etherscan, which is showing me that my contract was deployed and it is currently being indexed. You can see it is indexing. So after it is indexed, I can check the logs to find the emissions, the event emissions. Alright, so deployed, compiled and deployed. The next thing is to interact with the contract, and the interaction will be done in the main contract. So this is where we're doing the main interaction. We'll be interacting with the main contract. Alright, so we just expand it. Now let's check what we are asked to do here. It says that test contract interactions, make Ethereum donations using the fan function and verify the donation received event is emitted. So let's go and do some transaction. Okay, so you have to also know how to do transactions here, because when you click on this fan function, you are going to get error. You're going to get an error because, let me do it and you see, you get error. This transaction is likely to fail because you have to input an amount. So revert, you have to input an amount. Remember, we have a requirement that says that before you can use this particular fund, you must input an amount which is greater than or equal to the minimum USD, which is $50. So we have to add an amount here before we can deploy, we can call the fund function. Okay, and to do that, now here we have this particular unit of conversions. We have Way, we have Gway, we have Finny, we have Ether. Okay, and we need $50. Let's say we want to donate $60 into the contract. So we're going to call the fund function so that we can fund the contract. We want to input $60. How do we do that? Because here you cannot just, we don't have a dollar sign here. Okay, we have Way. So let's first go and check. Let's go to Google and then we do some conversions there, then we copy the figure. Let's look at $50 will give you what diggers or what units in Way. So let's go to here, let's come here. Then we say USD to Way. USD to Way. Okay, so I would rather say USD to ETH. This one I can get it very easily. So USD to Ethereum. So I'll say $60. So I want to donate $60. Now the reason why we are doing it this way is because we are testing on Remix. If after here you will build your front end and then you now implement that, you don't need to come here be doing all of these conversions. Your front end will handle all of these things. But now we are just going to do testing on Remix, and we need to do these conversions and copy the diggers because here we don't have a unit, a USD unit. Okay, so that's why we are going to have the unit $50 unit in way. So I will just copy that digit and come and put it here. Okay, so here we have $60, which will give you 0.018 Ethereum. So I'll copy this. Now let's go and look at Ethereum to Ether to way conversion. Okay, so we use alchemy. Okay, now we have copied Ether, and then we want to get it in way amount. So I just put it here, and great, we have way here. This is what we want. So we copy this one. Then let's go back to remix, and then we input it here, something like this. Okay, now we have a value. We can now go and call the fun function. We can now call the fun function since we have a value here which is more than $50, so it is more than the requirement. We can now call the fun function. Just click on fun. Okay, click on fun. Then let's see what happened. Okay, MetaMask popped up for me to confirm. It says transaction request, estimated changes. You send 0.018 Sepolia Ethereum. Request from Remix, what and what. Interact with the contract address, network fee, and I am charged $2, $2.7, speed, this and that. Right, so I'll just confirm. And I'm waiting for spending. Good. So transaction is successfully. Now the reason why the transaction is successful is because the amount that I inputted is more than $50. So you're either going to put $50 or equivalent of 50, either more or equivalent of 50 before the transaction will take place. Okay, so now inside this particular contract there is now a value, and if I check here, if I check on okay, so if you check on funders, if I put like 0, index 0, and click on funders, I should see my address. So this is the address I funded. So I can check, I can get the index of each address that fund this particular contract. And if I click on owner, this one should display the owner, the person that deployed the contract. Okay, so now we have an amount inside the contract. If I click on withdraw, I should be able to withdraw the funds. If I click on withdraw, I should be able to withdraw the funds. Now a MetaMask pop up for me to confirm that I want to withdraw it. And if I click on withdraw, it will withdraw all the funds inside the contract. So that's how simple it is, and you can do all the testing. After this, you deploy your contract, you can do all the testing, and then yeah, you are done with the project. The next thing you need to do is make sure that after you deploy, copy the contract addresses, then create a readme file here. Create a readme file here. Readme.md, and then say donation app, a donation contract address, equal to, then get the donation the one you deploy, the donation contract, get it, copy it from here, then put it there. And then second, price converter contract address, and then paste that one to here. Okay, no, I didn't copy it wrong. I have to copy it, and then put it there. So this is what you need to do. When you get to this level, you must have a readme. Then after you get your readme, then you get these contract addresses listed, because we have to check to see that you have really deployed your contract. So you get this in your README, and then you can now push your code to GitHub, and then submit the repository link as part of the week project requirement. Right? So thank you so much for watching, and I hope this will help you to implement your project, to create your contract and deploy on the Ethereum Sepolia network. Alright, so see you later.